Seaborn is a statistical plotting library in Python. It's built on top of matplotlib, which means when you run a Seaborn command, it runs a set of matplotlib commands under the hood. It's built with beautiful default styles for the graph, which makes it easier to read and comprehend. Seaborn is designed to work very well with pandas data frame objects, and therefore it's the go-to library for plotting data in Python. To install the Seaborn package, you would need to use the commands conda install Seaborn if you are using the Anaconda prompt, or otherwise pip install Seaborn if you are using the command prompt. So Seaborn can be used for analyzing different types of data by using different types of plots for numerical data, for categorical data, and even for data in matrix format. So let's start by importing our libraries and some data to work with. So here we will import numpy snp, import pandas spd, import matplotlib.pyplot splt, import seaborn as sns, and we will run a one line code matplotlib space inline. So this last line %matplotlib space inline, this will help to see the visualizations in the Jupyter notebook. Next, we will upload the dataset. So Seaborn comes preloaded with some datasets which we can use for practice purposes. So one of such datasets is called tips. To load the datasets, we can run the command sns.load dataset and just pass in the tips. So we can check the doc string here. It says load an example dataset from online repository. So this function provides quick access to a small number of example datasets. So we can use it for our practice as well. Let's run this. It will load the dataset. So let's check the head of the dataset. So this is our dataset. So it looks like it's from a restaurant. We have the total bill and we have tip data, and then we have some other categorical data. Now let's check the info. So in total it has 244 entries, range index going from 0 to 243, and 7 columns. Total bill, tip, sex, smoker, day, time and size. There are no null values here, and as we can see, the first two columns, total bill and tip, are float data. Then the next four are categorical data, and the last column seems to be integer data. So now that we have our data, let's move on to the matrix plot. Matrix plot allows us to plot data as color encoded matrices and can also be used to indicate clusters within the data. So the data for matrix plots has to be in a matrix form where both the index and column have some variables or categorical data, and the matrices have some sort of numerical data which relates to both index and column. So basically the data has to be in a tabular format where both the index and column are categories. So the data relate to both index and column in some form. The example of a matrix could be a pivot table, or it could be a correlation. If you find correlation between different numerical columns in a data set, whatever it returns will be in matrix form as well. So for this we need to import a new data set. So in Seaborn we have a data set called flights data. So let's use sns.load underscore dataset and just pass in the keyword flights. If you want to look at the doc string, we need to pass in the name, and then we have some other options which you can ignore. Let's check the head of this data set. So here we have only three columns. We have a year column, we have a month column, and we have passengers. So this is basically the number of passengers for some airline. for this given year and month. So let's look at the info to understand this data set in more detail. So total there are 144 entries ranging, row index goes from 0 to 143, and just 3 columns, no null values. We have integer for the year and for passenger, and we have month. So this data we can arrange in a matrix format. So let's say we will use pivot table here. We will name the variable fp. What we will do is flights dot pivot table, and here we need to pass in the values, index and column. So for index we will use the year column. For column we will pass in month, and for values we will pass in the passenger. So let's check this data. So here what we have now is we have a index which is for years, which goes from 1949 to 60. Then on the columns we have all the months, which goes from Jan to December, and then we have all the remaining data arranged in a tabular format. So you can see that for year 1949, for January there were 112 passengers, 118 for Feb, 132 for March. Similarly for the year 1956, let's say for December there were 306 passengers. So now we have our data in a matrix format. Now this is a very complicated table. You cannot just, it's not very intuitive. You cannot just read it and say where the data was high and where the data was low. You cannot infer information. This is a very complicated table. You cannot just infer information just by looking at this. So it's much easier to use a heat map here. The heat map will just put colors on this each individual cells to make it visually understandable and intuitive. So what we can do here is sns.heatmap, and for data just pass in this table. The name of the table is fp, so just pass in that, and here you can see the table has now been encoded with a color combination, and we have a scale here. What you see in the scale is we have a lighter color for higher numbers, which is around this part of the table, and we have lower numbers for, we have darker colors for lower numbers, which is at the top of the table. This is not very intuitive. I like to change this. So if you look at the parameters, we have a CMap parameter, which is for color mapping, the mapping from data values to color space. So what you can do is use this CMap, and you can use any color combination which you want. Let's say cool warm. So here cool warm has blue color, which is lighter for the lower numbers, and then it has red for darker. But if you look at this in the middle, it is very light, and it's very much darker on the both ends because it's divergent. So let's use another palette here. Let's use magma. So this goes from lighter to darker, but it's on the downside. We can use magma underscore r to reverse this color combination here. So now the lower numbers are lighter in color and the higher numbers are darker in color. And now this table is much more intuitive. You can see most of the passengers are around the summer months of the year 1960. As we go from left to right in the table, most of the passengers would be in the middle because most people would be traveling in the summer months for vacation, and lesser number of people would be taking flights in winter months like Jan, Feb and November and December. So there should be lesser passengers in those months. Similarly, as you see, as we go from top to down, from the year 1949 to 1960, we will get more and more passengers in the later years than in the earlier years. That's why you see the 1949 and 50 years are much more lighter compared to the rest of the table here. We can plot heat map for our earlier table as well, for the tips data set. For the numerical columns in that data set, we can find a correlation. So let's call that data frame TC, and let's find the correlation for that. Could not convert string to float. It is trying to find the correlation for the string columns as well. And here if you see, we have a parameter numeric underscore only, which is given as false by default. It used to be true earlier, but now they have changed it to false. I'm not sure why they did it. But if you just pass this and now check this data frame, this is a correlation data frame just for the numerical columns. So obviously the correlation for total bill, which is univariate, is 1. Then the correlation of total bill with tip is 0.67 and with size is 0.59. So there is moderate positive correlation between these variables. So we can plot a heat map using this data. And here once again the data goes from darker to lighter. So you can pass in a CMap for this. Let's use magma color here. And let's use the underscore R reverse for this color combination. So now it goes from lighter to darker. Now there's another parameter here which is called annote. So if this is true, it will write the data value in each cell. So let's pass that. Annote is true. So the values you see here in this table, those would be written over here as well. So it makes it easier to analyze. We could not have used annote here for this table as there are a lot of smaller box and it will become very complicated if you put annote here. So you cannot read this. So it's better not to use annote with heat maps like this. But here we have much bigger boxes, so we can use annote with this heat map. So next we will move on to the cluster map. Cluster map is very similar to heat map, but what it does additionally is it clusters the similar data together for both row and column. So it uses a hierarchical clustering to produce a clustered version of heat map. So the data which are similar will be clustered together. It will cluster all the rows together and all the columns together based on similar data in the matrix. So we have our flights data once again. Let's see, check this FP. Let's say we want to use cluster map for this. So let's pass in our data, which is FP. Now the size of this is very big. We can reduce the figure size here. We have the fixed size parameter given, which is 10 by 10 by default. So we can, let's go with 7 by 7, or let's go with 5 by 5 so that it fits in here. Let's try 6 by 6. This is too small. Yeah, so now it fits in nicely. Once again we want to change this color combination as the higher values are denoted by lighter color, which is not very intuitive. So I will go for magma underscore R. Underscore R at the end of any color combination or this color palette reverses the palette the other way. So if for magma the lighter color was for the higher value, now the lighter color would be for lower value. So compared to heat map, when we plotted the heat map for this flights dataset, here you can see on the y-axis the years went down from 1949 incrementally to 1960, and similarly the month went from Jan, Feb, March all the way to November and December in the heat map. But when you see that same thing in the cluster map, we have Jan, Feb, and then November is combined between Feb and March. Similarly, December comes between March and May, and then April comes after it, and the summer months like July, August are put together, and this is clustered along with the fall and spring months of June, October and September together. Similarly, on the y-axis as well, you can see the years are not in the same manner going from 1949 incrementally to 1960, but the years 1959 and 60 are clubbed together in the middle, but the other years are arranged separately. So here we have another parameter called standard scale. If you pass in 1, so it will change all of these without this standard scale. If you see, we had this colors intensity going from 200 to 600. If you use this standard scale, it will go from 0 to 1. So it will standardize all of the colors here. So next, let's move on to the grids.